So we are moving to the seventh session of a chemistry online class, and we were discussing about acids, bases, and salt. In the last class, we were discussing about a pH indicator. It is also called as a universal indicator. pH indicator, it is used to identify acid, bases, and neutral substances. Other indicators like litmus indicator, methyl orange, phenolphthalein, they are not used to identify the neutral substance as weak acid as well as a weak base. That is the advantage of using the pH indicator when compared to the other indicator. So the pH indicator is also has been made by combination of so many different color dyes. So pH indicator works based on the pH number and the pH color. That is what we have been discussed. And pH, it stands for potential of hydrogen, H plus ion concentrations. And based on the H plus ion concentration, pH number has been started from 1 to 14, and the pH number 1 says it is a strong acid, and pH number 3.5 to 6.5 weak acid, 6.5 to 7.5 considered to be a neutral. It means that it can be a weak acid as well as a weak base. That shows that both acidic strength and basic strength are equal when the pH number is 6.5 to 7.5. That is the reason we call the substances as a neutral substances. So neutral substance doesn't mean that they are acid or base. Understand? They are equal in the concentration of acid as well as the base. Then we understood the chemical properties of acids as well as a base, how acids and bases react with other chemical substances. So in the first one, we saw what will happen when acids are added to the metal. It forms salt and then the hydrogen gas. When acids react with the metal, it produces a chemical salt and a liberate hydrogen gas. And hydrogen gas is highly explosive in nature, and this reaction is exothermic also. So how do I identify that the given gas is hydrogen gas? Hydrogen gas produces pop sound when it is passed through the flame. So that was the first chemical property when we have been discussing. The second chemical property is that bases do not react with metal. Like acid, bases don't react with metal. But however, sodium hydroxide, it is a strong base. Sodium hydroxide is also called as caustic soda. So sodium hydroxide has the ability to react with zinc to form sodium zincate and then the hydrogen gas. So this reaction is very peculiar, not as usual with the other bases. So remember, base do not react with metal. So what is the reason why bases don't react with metal? Anybody can answer? Why bases don't react with the metals? 52. I think everyone has joined. Why bases don't react with metals? Hello, are you all there? Why base don't react with metal? Harish Kumaran, Akshita, Sudarshan, Shivani. Can you all respond? Are you all there on the
Master,
online?
yes, master.
Okay,
Can I
why
check,
bases?
Master?
Why they don't react with metal bases?
They do not react because metals have basic properties.
Yes, very good, Saujanya. So the bases also has a basic in nature, and metals also they are basic in nature. So when you add one base to another base, definitely it is not going to react. I think are you all actively present in the online class? That is raising a question in my mind.
Yes,
That
master.
okay, fine,
Yes,
very
Yes,
Master.
good.
master.
Yes, yes. So that is what we discussed in the last class. Okay, so today we are going to continue with the other chemical properties. So we are going to see how acids are going to react with metal carbonate. So last time we just saw how the acid is reacting with the metal. Now this time we are going to see the metal carbonates. Okay, so if when you ask about metal carbonate, what are metal carbonate? Metal carbonates are one kind of a chemical substance. The specific name has been given metal carbonate. That indicates that these chemical substances are formed when metal combined with the carbonate. That is why they are called as metal carbonates. Okay, this reaction, so when you add acid with the metal carbonate, they are going to react to form a salt as well as the carbon dioxide gas and water. Since it is a carbonate salt, definitely they release the carbon dioxide gas. So this reaction is also called as a neutralization reactions. So why neutralization reaction? Metal carbonates are basic in nature and acids and with metal carbonate. It means acid and base reacts together to form salt as well as water. So it is also called as a neutralization reactions. So neutralization, the term indicates acid and base, they exchange the ions H plus and OH minus ion. So acid and base bringing the neutral substance is called as neutralization reactions. So this reaction also is an example of a neutralization reactions. And here I have given the general equations. Acid plus metal carbonate is going to form salt plus carbon dioxide gas plus water. So this is how a chemical equation can be represented when there is a reaction between acid and the metal carbonate. Same material, same information, you can write it in your classwork by looking at the slide. You can write all the slides because I have given only the less information. You can just take it down in your classworks later on. So what is the example? So acid, I have given the acetic acid, and we all know acetic acid, it is present in the lemon, and sodium bicarbonate, which is also called as a baking soda. And when you add this acetic acid and baking soda together, they are going to form a salt called as sodium acetate, and they release the carbon dioxide gas as well as the water. So I think this reaction maybe some of you would have been performed when you have been there in the junior classes in making the presentations, that volcano. How many of you tried out making the volcano? Volcano eruption.
Yes, sir. Me.
Master, I have tried, master.
Yes. So how have you been observed when you add these things?
So the vinegar mixed with baking soda, it
Ah,
reacts.
oh, okay. So if you have been observed this reaction would have been so quick that it releases carbon dioxide gas immediately, and this reaction will take place within less time, within a fraction of seconds. This reaction occurs. So this is what the reaction between acid as well as the metal carbonate. Same reaction they are also using in the fire extinguisher. If you see the soda acid fire extinguisher, they are also same reaction. So acetic acid will be kept inside the glass vessel, inside that extinguisher container, and that baking soda will be around that glass container. So once if you press the knob on the top of the fire extinguisher, it will break the glass vessels. So immediately acetic acid will be combining with baking soda, and that releases the carbon dioxide gas. So that carbon dioxide gas has been used to extinguish the fire. So this reaction is also used in the soda acid fire extinguisher. So this is the another property how acids will react when they have been added with the metal carbonate. Very simple. So acids are added with the metal carbonates. Metal carbonates are basic in nature. So this reaction is also called as neutralization reactions. When acids are added to the metal carbonate, they release carbon dioxide gas and water and salt. So why they release carbon dioxide gas in the sense, since it is a metal carbonate, the carbonate from the metal has been broken down by the acid and they release the carbon dioxide gas. So that is one of the reason why it releases the carbon dioxide gas. And the example is acetic acid, sodium bicarbonate, and it gives sodium acetate, and then the water and carbon dioxide. And generally, maybe I will take the highlighter. So let us understand how to write the metal carbonate formula. Again, we are going to use the knowledge of our 9th standard, what you have learned in 9th standard only. And carbonate, we know that it can be written as CO3 2 minus because it is a non-metallic property. So CO3, one carbon molecule, 3 oxygen molecule, and 2 minus is the valency of carbonate ion. And I have also given the list of metals with valency. So lithium Li plus. So if you want to write the lithium carbonate, so it is Li plus, and the carbonate is it is C. So carbonate is CO3 2 minus. So if you cross the valency, the metal carbonate formula, it will become Li2 because the 2 comes over here, and you will be able to see the CO3. Okay. So this is the metal carbonate. So generally metal carbonate can be written in this way. So the lithium carbonate. So that is the name of the compound what I have written on the screen. Did you all get it? How to write the metal carbonate? So Li2CO3 lithium carbonate. So this is a metal carbonate. So suppose I want to write the equation. So how do I write? You can take any acid. So which acid? Let me take hydrochloric acid. I am taking hydrochloric acid. Okay. You should also practice not coming properly. I take hydrochloric acid can be written as it is HCl, and the lithium carbonate it is Li2CO3. So that is a lithium carbonate Li2CO3. It is a lithium carbonate and it is added with the hydrochloric acid. Now how do I write the product? Definitely. So you need not worry about it. So H plus and Cl minus. We know that hydrochloric acid can be broken into H plus and then Cl minus. Lithium carbonate is already available. Can you all see that? Lithium. So combine that H plus and this Cl minus with this Li plus. I am joining here. Okay. Then it will become LiCl. So that is a salt. What is formed? Okay. LiCl plus it can also release the H2O. Definitely, since it is a neutralization reactions, it will form salt as well as a water. If it is a neutralization reaction, definitely they form salt as well as water. So did you all get it how to write the equations? Very simple. You can write n number of equations that you want. Say with the lithium I have written it. So similarly I can, instead of using the hydrochloric acid, I can also use a sulfuric acid. I can also use a nitric acid. So sodium, potassium, magnesium, calcium, aluminum, silver, copper and ammonium and iron. So this is how the metal carbonate will react with the acid. Very simple. If you want to learn the chemistry as easier as it is possible, you need to have a lot of practice, just similar to your mathematics. Until and unless you practice all these equations, formula, it will be very difficult. And another thing is that you will feel that, oh, what is happening with the reactions? How do you write the chemical symbol? You will have a lot of confuses. So better have a good practice, and the chemistry will be very easy. If you understand, it is really so easy. You need not to memorize. But if you don't understand or if you don't practice, then it will be a big issue. Okay, hope you understood about the metal carbonate and how to write the equations when acids are reacted with the metal carbonate. If any of you have a question, please raise it over here. Anybody have a question regarding in this, how to write the equations or how to write the formula for metal carbonates? Hello?
No, master.
Okay, so shall we continue to the next reaction?
Yes,
Okay.
master.
Yes. So I have given some of the examples like sodium carbonate. It is Na2CO3 and it is added with the HCl and it forms sodium chloride. It is a salt and H2O plus carbon dioxide gas. So this is the neutralization reaction. So remember, enormous amount of carbon dioxide gas will be released. So if you observe all these reactions, we call as a effervescence. So the term what is used to describe the formation of carbon dioxide gas is effervescence. Remember, even in examinations also, sometimes they will give you the hint only. A gas that is released with brisk effervescence. It means that it indicates a carbon dioxide gas. Effervescence means like a foam like things that comes out very easily. Okay, like a foam, it comes out of the vessel or comes out of the test tube or the boiling tube. That is the meaning of effervescence. So this carbon dioxide is the effervescence gas. Remember, okay. So sodium carbonate is reacted with the hydrochloric acid. It has formed the sodium chloride, water as well as a carbon dioxide gas. Maybe again I will show you how this reaction has happened. So we know what is the valence of sodium. It is Na plus, and the carbonate we saw that it is CO3. It is CO3 2 minus, that is a carbonate, and hydrochloric acid we know that it will be divided into H plus and then Cl minus, it is a chlorine. So H plus and then so it is going to form H plus and Cl minus. So it will, if you combine that Na, so it will be combining with the Cl, then it is going to form a NaCl formula. Then CO3 will be converted into CO2, and whatever the H plus is there, it will combine with the excess amount of oxygen present in that carbonate. It is becoming the H2O. So this is how this reaction has happened, and that is how we need to write the chemical equations also. The next example is aluminum carbonate. So aluminum valency is Al3 plus, carbonate is CO3 2 minus, again H plus and Cl minus, it will become AlCl3, then it forms H2O and then the carbon dioxide gas. So all the equations has been balanced, and you need to mention the state of the matter also. Suppose I am writing aluminum carbonate, it is a solid only, okay. Hydrochloric acid has to be written as AQ, aqueous. So aqueous in the sense it has to be dissolved into the water. Aluminum chloride, it is the salt, then H2O, then CO2. And we can also use the symbol. Suppose if you use the up arrow mark, that indicates that there is a formation of the gas. The third equation is sodium bicarbonate is NaHCO3. Sodium bicarbonate can also be called as baking soda. So it is also called as baking soda. And then the baking soda is added with the HCl, it forms NaCl, H2O, and then the carbon dioxide gas. So this is how the acids will react with metal carbonate, a simple chemical reaction. Okay, so understand. So even if it is metal bicarbonate like hydrogen carbonate, same reaction only is going to happen. Is this clear? Any questions regarding this?
Excuse me, Master.
Yes, yes.
Master Edwin, when you answered the previous slide, Master.
Okay, you want to get the previous slide. Okay. What
Master,
is the
he
question
couldn't
there?
understand the reactions of the acid, Master.
Which reaction? This one. So this is okay. In this one, I have just explained about what are metal carbonate. They are the salt, and how to write the formula for metal carbonate. So I have given the list of metals: Li plus, Na plus, K plus, Mg2 plus, Ca plus, Ca2 plus, and carbonate. We all know it is a polyatomic ion. Carbon 3 oxygen combined together, it is becoming the valency 2 minus. Minus indicates that they are the anion. They have the ability to receive electron. So if you combine the metal and the carbonate, that is what is called metal carbonate, because metal carbonates, so metal carbonate is going to react with acid. So this slide is to just understand that what are metal carbonate. Is this clear, Edwin? So you need to have a practice of writing this Li plus CO3 2 minus. So this is how we create the formula for metal carbonate. So this and all I have given extra for your better practice. Okay. Maybe in the book they would have been given only 2 or 3 formula that you can go with that. But understand how the formulas are getting created so that it is very easy to remember. Is this clear, Edwin? Shall we go with the next slide?
Yes, Master, he told it's clear, Master.
Very good. So in this slide, we just saw how that acid is reacting with the metal carbonate. So acid, we know the split up. Acids are highly corrosive, so immediately they will react with the base to form a salt, water, and then the hydrogen gas. So this is the salt. Suppose aluminum chloride, and then the water, and you are also having the carbon dioxide gas. So very simple reaction. So I have given 3 examples. You can also, now I have done with the HCl. Please you people try to do with sulfuric acid and nitric acid. And in the last class I told you to write more than 30 equations. Am I right? Metal plus acid, how many of you have done that practice? Is there anyone who has written more than 30 equations metal plus acid? Hello,
Yes, Master.
please respond. How many equations did you write? What is your name?
Master, my name is Sudarshan, Master.
Did you write, Sudarshan? How many equations have you written?
Master, I wrote 30 only, Master.
Very good. How do you feel? Was it
Master,
easy or tough?
Master, little bit tough, Master.
Okay. So the best thing is that you should know the valency of that metal, like Li plus, Na plus, Mg2 plus, Al3 plus. That's all. And hydrochloric acid H plus Cl minus, sulfuric acid H plus SO2 minus, nitric acid H plus and NO3 minus. So this is not something very new in the class 10. Okay. Maybe what you are learning in ninth only. Yeah. So just you have to remember these balances, and just it is like your puzzle only. You have to split and you have to join. Okay. So no problem. Initially it may be a little bit difficult, but keep practice. There is a only way. Okay. Always starting up will be like that only, but you can have a lot of practice in that. Okay, good, Sudarshan. At least you have been written 30 equations. Don't stop it. Keep moving it. See, once you have this kind of practices now, you will have a wonderful learning of chemistry in the future. Don't worry. Okay. So I will go to the next slide. Maybe I will show you the video where the reaction between that acidic acid and baking soda has been carried out, that releases a more amount of carbon dioxide gas. That is what this video will show you. So I have also written the equations. A reaction of vinegar with the baking soda. So the vinegar is nothing but acidic acid. The formula is CH3. Someone is speaking. Who
The
is that?
Sushant's mic is on, Master.
Okay, okay. Mute the mic. So I will show you the video about vinegar with the baking soda, and down I have written the equation also. So acetic acid, it is a CH3COH, and baking soda is NaHCO3. So CH3COONA. I'll show you the split up also. So acid plus metal carbonate, it is going to form. Just watch the video. Meanwhile I'll write it down. So baking soda is also called as sodium bicarbonate, NaHCO3. It is a metal carbonate. Is just pouring the vinegar. The next one is a baking soda. That baking soda is added to the balloon so that to collect the carbon dioxide gas. You can see that some amount of baking soda is added to the balloon. You can is going to cover the bottle with the balloon. You can see the reaction. See, immediately it is releasing the much amount of carbon dioxide gas. That is why it is called as brisk effervescence. So the carbon dioxide gas will be released very quickly and immediately. So you can see that all the carbon dioxide gas is collected over the balloon. This you can try it in your house. I think you all have the kit. Very simple. Vinegar and baking soda, nothing else. So carbon dioxide that is produced takes up the space in the inside the balloon. The air inside the balloon is now denser than the other air. So what will happen to this balloon? You can try out this. Very simple. Usually, the balloon immediately it will not come down to the earth, but carbon dioxide gas is little bit heavier gas when compared to the other gases. So it is more denser. So this reaction you can, in a simple way, you can carry out. You can do it. And maybe some of you may have a doubt. Why do we use baking soda in the process of baking? Okay. Can any one of you can you guess how this baking powder will help us in baking process, and why what is the need of using this baking soda into the cooking purpose? Can you guess the reason now? Hello, anybody is there?
Master, can I say, Master?
Yes, yes, please.
Master, they use baking soda in hotels because, Master, when we eat baking soda, Master, it gets reacted with the hydrochloric acid in our stomach, Master, and it get neutralized so that we feel complete and satisfied, Master.
Okay, who is that?
Pritish.
Pritish. Okay, good, Pritish.
Thank you,
Uh,
Master.
but, but remember, it will be neutralized. But why the baking soda purpose is not that. And moreover, our saliva, that salivary amylase, what is secreted in the tongues, buds, has the ability to neutralize the food. And I told saliva can be the acid as well as the base depending upon the food that you consume in your body. Okay, the baking soda when it they usually in our house day to day life we use baking soda for making that idli or dosa. Very simple. What is going to happen in the sense, and this baking soda when it is added to that it reacts the acid, natural acid what is present in it, and it will release the carbon dioxide gas. Because of that carbon dioxide gas only it will give the smoothie, like that puffiness stuffs gets increases, it will become very soft, your idli or dosa. Even when you are making the dosa also you'll able to find out the bubbles, some holes will be there. It's all nothing but that release of carbon dioxide gas. We call this reaction also fermentation reaction. That is a one way. In bakery when they make the bread, they need the buffness, it has to be very soft. So they use this baking soda. So that baking soda, usage of baking soda increases the fermentation reactions. At the same time it also releases the carbon dioxide gas. Because of that carbon dioxide gas only it is very soft. Okay, so that is the reason why they use this baking soda. That is a good try, Pritesh. Anyway, so understand that is a simple day-to-day life applications. The next thing is that we go with the reaction of base with metal carbonate. Definitely, what is going to happen? Bases do not react with metal carbonate because metal carbonates are weak bases. So definitely they don't react. So we can write equations, no reaction. But however, if you write the equations, it comes out as base plus metal carbonate is form the no reaction. So is this clear? So far we just discussed the two chemical properties. One is acid plus metal. When then we saw base plus metal. Then second one is acid plus metal carbonate and acid plus metal bicarbonate. Then base plus metal carbonates. Okay. So these are the chemical properties of acid and bases. Okay. So that is how the chemical properties. Okay, the next one is, so we'll go to the physical property. So what is going to happen to the acid when I'm adding to the water? We discussed in the first class itself that all the acids has the ability to dissolve into the water. So acids dissolve in water to form hydronium ion. These hydronium ions liberate heat energy. So what is hydronium ion? When you add acid to the water, maybe I will show you. Suppose you are taking the water in a beaker. Suppose you are taking a small amount of water in a beaker and we are trying to add acid to the water. So it will dissolve. You will not be able to see the separate layer. The acid easily will diffuse into the water. So when they diffuse into the water, they release the ions. So if we take the HCl, hydrochloric acid, and this hydrochloric acid can be divided into H plus and then the Cl minus. So that is how ion will split up. So this is called ionization. So when you add acid to the water, it is going to split into H plus and Cl minus. If it is a sulfuric acid, it is going to form H plus and then SO2 minus. If it is a nitric acid, it is going to form H plus and then the NO3 minus. So this H plus will combine with water H2O and it is going to release hydronium ion. So this hydronium ion is exothermic in nature. It means it will release the heat energy. So this is what will happen when acid is added to the water. You need to imagine these are all the ionic level. Okay. So when you add acid to the water, they release the ions. These ions are combined with water to form a hydronium ion. These hydronium ions are highly exothermic in nature. They release more amount of heat energy. Is this clear? Any questions over here? Are you all there?
Yes, master.
Sir,
No
no
questions,
questions,
master.
sir.
Okay, okay. So this is how the acids will happen when they have been added with the water. So I think whatever I have done in the last slide has been carried out to this slide.
Sir, excuse
Excuse me,
me, sir.
master.
Yes, yes.
So Edwin is asking that is ionizing process responsible for changes of chameleon skin color?
Yes, 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 Edwin. Correct only. Chameleon color when you have been adding different colors, especially the glucose added to the potassium dichromate, they undergo a continuous oxidation process. So they change the exchange ions. So because of that only they change their colors. I think is this slide is very clear right now. Why
So
should we
yes,
have
master, clear, master.
some scribbling is there or not?
So it's
No.
okay, master.
Actually, I have done in the last slide, but it has come in this slide. Okay. So remember why we should always add acid to the water. So there is a way you can dilute the acid to the water or water to the acid. However, in both the ways it can be done. But which is the safe method? Please understand this is very important. When you are adding acid to the water, what is happening? When you are adding water to the acid, what is happening? Before both are liquids, acid as well as the water. But understand that acid is more denser than the water. So when you add acid to the water, immediately acid will go deep of water. It will get sink inside the water molecule. That is the first reason. Please understand it. Acid is more denser. So when acid touches the water, It sinks inside the water molecule and forms hydronium ion. I told you these hydronium ions are highly exothermic in nature, so they release heat energy. But since the acid get inside the water, this heat energy gets shared between the water molecule. So it is not explosive. It will not explode or splash out of the water content. So when you are diluting the acid, always remember that acid should be added to the water. What is going to happen if water is added to the acid in another way? When I add water to acid, I told you the water is a very lighter molecule. So a small drop of water liberates, it creates more amount of hydronium ion from the acid. So all these hydronium ion will be on the surface of acid. So when it is on the surface, immediately it will splash out of the container. It may splash out of the test tube or the boiling tube or the vessel that you have been adding it. So what is going to happen? It may fall on your skin, or it may irritate the skin, or it may be corrosive in nature. Okay, or the glass vessel, sometimes they may break down also due to the excess amount of heat. Sometimes the glass vessel also may broken down. So understand that when you are diluting the acid, you should always add acid to the water but not water to acid. Of course, in both the way it is getting diluted. After, after adding acid to the water or water to the acid, the reaction will come down and it will be diluted, but immediately it may cause a splash, acid splash, especially when you are adding water to the acid. So a small drop of water is enough to liberate more amount of hydronium ion. Okay, so that is why we should always add acid to the water but not water to the acid. I think some of you will have definitely doubt. If you have any questions, you can ask over here. Any questions?
Master,
Yes, yes.
I'm Arjun, Master.
Yes, Arjun.
Master, all acids are denser, Master.
All acids?
All acids are denser, Master.
Yes, yes. And if you add the organic acid like citric acid or the orange, you can just observe. You just squeeze the small amount of lemon on the surface of the water. Just try to observe. Immediately it will sink. It moves down fastly. You can just check it out. Suppose the vinegar is there. Just take a vinegar and add a few drop of water on the surface of vinegar, and then see whether it gets inside the vinegar or just stays on the top of the vinegar. You can just observe this, Arjun. It is a good question only. But organic acids will not release much amount of heat energy. Remember that. Okay, depending upon the strength of the acid. Strong acids are highly exothermic in nature, definitely no doubt. But when you are diluting the that lemon juice and all, it is not much exothermic in nature. Organic acids are, since it is a weak acid, they do not form a powerful hydronium ion and they will not release much amount of heat energy. Did you get it, Arjun? Okay. So
Yes,
that is a
Master.
good question. Maybe others also can understand that what will happen with the organic acids. So strong acids will cause highly explosive in nature, but weak acids, they do not cause much amount of heat energy over there. I think maybe 1 minute. PowerPoint slide. Okay, the next one is what is going to happen with the base. Dilution of base. So bases dissolve in water to form hydroxide ion, and it is also exothermic in nature. So remember, acid means they combine with water to form hydronium ion, but bases combine with water to form hydroxide ion, OH minus. So NaOH plus H2O gives Na plus and then OH minus. But all bases do not dissolve in water. All acids dissolve in water, but all bases do not dissolve in water. Bases dissolves in water is called as alkali. I think we discussed in the first class also. So alkali means, understand that a base that has the ability to dissolve in water is called alkali. The bases that do not dissolve in water is called as non-alkali. So that is the dilution of base. So very simple, physical properties. So what is going to happen when the acids are added to the water and bases are added to the water? Acids, when it is added to the water, they liberate hydronium ion. So these hydronium ions are highly exothermic in nature, and it is the safest way of adding dilution of acid is that acid should be always added to the water, but not water to the acid. So when you are adding water to the acid, as soon as water touches the surface of the acid molecule, liberate more amount of hydronium ion. This hydronium ion liberate high amount of heat energy that may splash out of the container. So in a safe way, if you want to dilute the acid with the water, you must always add acid to the water, but not water to the acid. And the second thing is that what will happen when the bases are added to the water? All bases do not dissolve in water. A base that dissolves in water is called alkali, and a bases that do not dissolve in water is called as non-alkali. And here is the equations: sodium hydroxide (NaOH). The general name of sodium hydroxide is caustic soda. So NaOH plus H2O gives Na plus and then the OH minus. Okay. The next we come with the electrical conductivity of water. So what is going to electrical conductivity? Acid is added to the water, and if you pass the electricity, so what is going to happen? So all the acids are good conductors of electricity. All the acid will conduct electricity because they all consist of H plus ions, and bases are poor conductors. They do not conduct much amount of electricity. I think I'll get back to the PowerPoint slide. I think that is one of the reason why acids are all used in the battery, UPS battery. Do you all know which acid is used in the UPS battery? Have any idea? Do anybody know why we use acid in UPS? Because bases are good insulators. I think why acids are good. Instead of discussing in the chat box, yes, yes. Why acids are used in the UPS?
Master, to produce electricity.
Okay. We know that say in the UPS they use a lot amount of acids, and these acids release H plus ion, and this H plus ions helps in the formation of electron. Okay, so with these electrons immediately it will be conducted to the anode and cathode, then they form the electricity. Distilled water and zinc, master, distilled water and zinc lead. What is the question, Ishwar? I did not get you. What is the, because they contain H plus. I think better you people listen to the presentation instead of sending the things in the. Yes, yes. In UPS they have been used. Okay, distilled water in UPS they use the sulfuric acid. I asked which acid is used. Okay, so that sulfuric acid enables the conduction of electricity. So that is a one reason why they use the why they use the acid into the UPS. Okay, because all the acids are good conductors of electricity. So that is why one minute I'll open that slide. So that is a way that we use the uh, acid into the UPS. Okay. I think there is some problem with the UPS. Sorry, PPT. 1 minute. Okay, so this is how we discuss. So why we should always add and base. Okay, so electrical conductors. So bases are the good conductors of bases do not conduct electricity. So understand acids are good conductors because they consist of this H plus ion. Okay, so that is the one reason why acids. Okay, the next one is we are coming back to discuss the neutralization reactions. So as we discuss what is neutralization in the reaction in the sense when acids are added to the base, H plus ion from the acid and OH minus ion from the base react together to form salt as well as the water. So this is how they have been called as a neutralization reactions. So in acid we have whatever may be acid. So in all the acids we know that it is consist of this H plus. In all the base it is consist of OH minus hydroxide ion. In all the base there is a presence of ion, we call it as an hydroxide ion. When you combine this H plus and then the OH minus, it is going to form a water. So H plus and the OH minus together it is coming down as a water molecule. So that is how this reaction is called as a neutralization reactions. So I have given the example. What is a neutralization reaction? So NaOH. So NaOH plus HCl gives NaCl plus H2O. So if you split that NaOH, it is going to form Na. So Na plus and then we know that OH will be OH minus, so it is going to form a OH minus, and hydrochloric acid also will be there. So hydrochloric acid, we know that it will be H plus and then the Cl minus, H plus and Cl minus. So how to write the formula? Very simple. So combine this Na plus and then the Cl minus, it is going to form NaCl, and H plus and then the OH minus. So it is going to form a water. So that is why it is called as neutralization reaction, because acid and base, they get neutralized with each other to form H2O. So H plus and OH minus together to form a water molecule. So such reactions are called as a neutralization reactions. And can you say sodium hydroxide is strong base or weak base? Sodium hydroxide. Ishwar, tell me, sodium hydroxide is strong base or weak base?
It's a strong base.
Okay, hydrochloric acid.
It's a strong acid.
Very good. So if you say see that sodium hydroxide and the hydrochloric acid, so the reaction between strong base and strong acid. So the salt will be a neutral salt. When the strong acid and strong base reacts, it will be a neutral salt. All the salt is not neutral. That is what you need to understand. There are some salt which is acidic also and basic also. So here I have given the hint. So when there is a reaction between strong acid and the strong base, so it is going to form a neutral salt. Okay, remember. So strong acid, strong base, neutral salt. Definitely water will be formed. Strong acid and weak base, it is going to form a acidic salt. You know why? Because here the acidic strength is more, it is a strong acid, so it is going to form an acidic salt. Suppose weak acid and then this strong base, so weak acid is there and then this strong base, it is going to form a basic salt. Okay, and weak acid and weak base is going to form a neutral salt. So that is how the neutralization reaction takes place. So you may ask me, master, is there is an acidic salt? Yes, of course, there is a salt which consists of an acid, there is a salt which is consists of the base also. So all the salt is not neutral, please understand that. So when there is a reaction between strong acid and strong base, they form the neutral salt. When there is a reaction between strong acid and weak base, acidic salt, weak acid, strong base, basic salt, weak acid, weak base, neutral salt. So that is how the neutralization reactions will take place. In commonly in all the neutralization reactions, definitely there will be a formation of a water molecule. So this water is formed by the combination of, that is acid, so H plus from the acid and OH minus from the base. It is because of that all the neutralization reactions, definitely they release a water molecule, because base release hydroxide ion and acid release H plus ion. Because of these things, they are called as neutralization reactions. Any questions over here? Do you have any doubt? Okay. So today we'll just recall what you have been learned. So first we saw the chemical properties of acid and base. Acids react with metal carbonate to form salt, carbon dioxide gas and water. Because metal carbonates are basic in nature, and carbonates release carbon dioxide gas. And this carbon dioxide gas comes as a brisk effervescence. It means that high amount of carbon dioxide gas is released. That is what the meaning of brisk effervescence. And we know that this carbon dioxide gas will extinguish the fire. Then second thing is that bases do not react with metal carbonate, because the metal carbonates are basic in nature. So one base will not react with another base. Okay, that is what we have been learned. Then third thing is that acids dissolves in water to form hydronium ion. So how the hydronium ion? Hydronium ion is H3O plus. So this hydronium ion is highly exothermic in nature. So when they have been added to the water, they release heat energy, and because of that heat energy, it may splash out of the container. So we must always add acid to the water, but not water to the acid. So that is how acids will take place when it is added to the water. Then acid should be added to the water, but not water to acid. Okay, here this will not come. Acids are always good conductors of electricity. Bases do not conduct electricity. So we just saw that acids has H plus ion. So since they have the H plus ion, they are the good conductors of electricity. But bases do not conduct electricity. And acid and base, when they react together to form salt and water, such reactions are called as a neutralization reactions. It means that H plus from the acid and OH minus from the base, they react together to form a water molecule. And we also saw all the salt is not to be a neutral. So strong acid, strong base, neutral salt, strong acid, weak base, acidic salt, strong base, weak acid, basic salt, weak acid, weak base, it is going to form a neutral salt. So that is what we have discussed today. Okay. So any questions you want to ask?
So no questions, Master.
Okay. Maybe I'll come back there. Then we'll have questions.